Okay, hi Chem students, this is Miss Vannoni here. Today we're going to be looking at our first pass of significant figures. Okay, we're going to be using significant figures a lot this year, not only in class when we do calculations, when we get to things like the metric system or stoichiometry or any sort of conversion, but also a lot in lab because we're going to be taking a lot of measurements and a lot of different types of measurements in lab, and we want to be sure that we know how many of those digits as part of our measurement are significant or do affect our value, which will in turn affect our calculations. Okay, so here we go. So what is a significant figure? A significant figure are all of the digits that you get from a measurement plus one estimated digit. Okay, so that's kind of focusing in right here. Okay, so it's all, again, all of the digits you are certain of plus one estimated digit, because sometimes when you're taking a measurement, not when you're using it like an electronic balance or scale, but say we're using a triple beam balance or we're using a ruler, sometimes it can fall between two values and you have to make a judgment call of like, where between those two values does this object lie? Is it a 0.3? Is it a 0.4? You get to estimate what that digit is. So you're always going to have some sort of or some amount of uncertainty when you are taking measurements, right? And again, this is more when we're taking measurements by hand, when we're not using something electronic, because that gives us a very specific value, okay? The greater the number of digits in your measurement, the greater the certainty, right? So we want to think of the difference between a 10 milliliter graduated cylinder versus a 100 milliliter graduated cylinder. I can get much more specific with my 100 milliliter graduated cylinder because I've got more places in the value versus just 10 where there's a greater amount of uncertainty. Okay, so here are our rules for significant figures, okay? And you'll probably have gone over these in class, or you will go over them in class. So we want to kind of review here the rules when we're counting SigFigs, again, when we're taking measurements. These are all based off of values that are taken when we are taking measurements. We don't want to forget that. It always comes down to measurements. Okay, measurements, measurements, measurements. So we also call these the rules of zeros because they all in some way have to do with the number zero. So our first rule is all non-zero digits are significant. So anything valued 1 through 9, those are always going to be significant. They're always going to count those towards our total. So if you look at our example here, 123.4 has 4 significant digits because there's 4 numbers in that measurement, and they're all non-zero digits. Okay, we also want to keep in mind that the numbers that I'm giving you on this page, they're missing an important part of being a measurement. Remember, when you have a measurement, you always need a number and a unit, right? I'm missing my units here, so these aren't exactly right, but we're still going to count those numbers of SigFigs, okay? So anytime you have a leading zero, those zeros are not significant, right? So if you look here, you have all of these zeros leading into the number 6. None of those zeros are significant, okay? Think of it like a red carpet leading into something, right? None of those zeros are significant until you get to a non-zero digit. So that 6 is that first non-zero digit that we have. So 6 and 7, in this case, are our significant digits, meaning that those zeros don't count. Okay, so our third rule is going to be any captive zeros are going to be significant. So you want to think of this like a zero sandwich. Okay, if I have the number 101, this 0 right here is significant because it's between two non-zero digits. Okay, if I have something like 100, those are probably not going to be significant because they follow a non-zero digit. There's not another non-zero digit on the other side, right? So if I look at our example here, 8009.021 has 7 significant figures. Everything in here is significant because your zeros are all sandwiched between non-zero digits. Okay, and your trailing zeros are only going to count if there's a decimal. Okay, so here, if I have 56,000, or similar to our example of 100 over here, those last three zeros are not going to be significant because there is no decimal. But if I add that decimal right there, then all of the zeros become significant because they all follow a non-zero digit. Okay, so I understand these rules can be kind of confusing. You may want to rewind the video at this point, go back and take a look. Okay, let's look at some examples. Zeros. So what we want to do is practice counting sig figs here. Again, we want to keep in mind that if we're doing a measurement, which is where we use our significant figures, we do need a number and a unit. I'm again missing my unit, so we just want to keep that in mind. Okay, so this might be a good time to pause your video and try all of these examples, okay? Because I'm going to go to the answers on the next slide, and I'm going to go over why each one has the amount that it does. So this would be a good place to stop, try them for yourself, and then check your answers on the next slide together. So here we go. Here are answers for our previous slide, okay? So 0.0987 has three significant figures. The zeros in this case are not significant because they are leading zeros. Okay, so they don't count. In this case, 8.99990 has six significant figures. This zero does count because there's a decimal and it is following a non-zero digit. Okay, so it has a decimal. In this third example, the only significant digits are 8 and the last two zeros. All of these leading zeros don't count because they don't follow a non-zero digit. So there's only three significant figures here because we have leading zeros. 800 only has one because it has two trailing zeros and there's no decimal, but 800 with a decimal point has three, again because that decimal point makes those trailing zeros significant because they follow a non-zero digit. In number 6, you have 7 significant figures because these zeros in here count, again, because you have that decimal. And in this last one, there are 6 significant figures because this last zero doesn't count because, again, it's a trailing zero, no decimal. Okay, so again, you may want to check your answers. Go back and try a couple times if you want. When we do calculations with our measurements, okay, you are only going to be as certain as your least certain measurement. So you're only going to be as good as your value that has the fewest number of significant figures. So when we talk about multiplying and dividing, okay, which is what we're going to focus on in this slide, okay, we are looking at your answer having only the same number of significant figures, or sig figs, as your measurement with the least number of significant figures. So if we look at our example here, we're doing 23.413 multiplied by 7.900 multiplied by 0.500. So in this case, our first number has 5 significant digits, our second has 4, and our third has 3. If you're unsure about why those are the correct number of significant figures, you want to go back to the previous slide, rewind our video, and check it out. So our answer should have 3 significant figures. Okay, so this would be a good time again, pause this video, try it out, punch in your calculator, see what your answer comes out to be, round it to 3 significant figures. And again, keep in mind good rules for rounding because your answer can only have the same number of significant figures as your measurement with the least number of significant figures. Again, I'm missing my units, which is a common mistake for me in this presentation, but we want to still follow all the good rules. Okay, so our answer here, if you put it into your calculator, comes out to 92.48135. But since we can only have 3 significant figures, 92.5 is our correct answer. Again, normally you would put a unit onto this to make it a full answer. And lastly, we want to talk about addition or subtraction. Similarly to multiplication and division, you're going to be looking at your number of significant figures, but your answer can only have the same number of decimal places, which is different than what we talked about before, as the value that has the fewest decimal places. So in our first number we have 2, nope. Our second we have 1, in our third we have 3. So our answer should only have one decimal place, right? Which is what we have right here. Okay? So again, multiplication division, we're looking at the number of significant figures. Addition and subtraction, we're looking at the number of decimal places. Okay? And here you go. This is some more mixed practice. You want to keep in mind your order of operations, multiplication, division, then addition and subtraction, making sure that you do things that are in parentheses first. Okay? So this would also be a good place. Pause the video, try these, make sure you have the correct number of significant figures, and then you can try to check your answers on the next slide. So here are our answers. In our first one, our answer is 5.40 because we have 3 SigFigs, because both of these numbers have 3 significant figures. Okay. Number 2, again, you've got a mix of functions, so make sure you do inside the parentheses first and then go outside. Our final, meaning that you should do the rules for addition for significant figures first to get to these 2 numbers, then do the rules of division to get to your last value here. So our answer has 4 significant figures because this number has 4. Again, but these decimal places are based off of this value to start. Okay, so you have a mix of functions there. Here's a simple subtraction. This only has 1 decimal place, so your answer only has 1 decimal place. And our last one is a multiplication equation. Again, this has 3 significant figures, this has 3, this has 4, so our answer should have 3. Make sure you pay particular attention to units. If it's a double unit like in number 1, grams over milliliters, or a cubed unit like in number 3 if you're multiplying. So you also want to keep in mind those certain things as you are doing your mathematics.